Welcome back to Quay Does Leetcode. Today I'm doing problem number 79, word search. So for this problem, you're given an m by n grid of characters called board and a string called word. And you need to return true if the word exists in the grid. So basically, for this example 1, we have a word A, B, C, C, E, D, and we want to return true if the word is in the grid. So you can go, you can look at, you start with a cell and you look for the word, the next letter in the adjacent cell. So for example, the word is A, B, C, C, E, D. So you see, we can see that this word exists in the board because we have an A, and next to that we have a B, and next to that we have a C, and it can be any adjacent cell, so up, down, left, or right. So down we have another C, down we have another E, and to the left we have a D. So the whole word is in the board. So it's easy to see, it's pretty straightforward to see if the word is in the board, just by looking at it. But how can we do this programmatically with code? Well, we can go with the brute force approach, which is, okay, we're starting with the first letter, we're looking for an A. We look for it across the board. So if we start at the first cell, 0, 0, we find our A. If we would have started with this cell here, we look for it. Is there an A here? It's not here, so we look for it in another cell. Is it A here? No, so we look for another cell. But since we're going in order from 0, 0, 0, 1, going across the board, we find it on the first try. So we find an A. So now we find an A. So now we're looking for a B. And so we look up. Well, there's no letter up, so we don't find the B. There's no letter to the left, so we don't find a B. There's no letter down, there is a letter down. The letter below is an S, that's not a B, so we didn't find it. And finally, we look to the right, and there is a B, so we found our B. And so then we do the same thing with C. We're on character C. We found B, so we're looking for character C. So we look up, we can't find it up, and we look left. Okay, we can't actually use the character left. If the character left was a C, we couldn't use that because we can't, the same letter cell may not be used more than once. So we can't use the, we can't go backwards, essentially. So, we don't want to go that way. And we go down, that's an F, that's not a C. And we go right, and that's a C, so we found it. And so that's how we're going to do this. We can use a backtracking recursive approach to basically start with a letter, do a depth first search, and in 4 directions, up, down, left, right, to see if we can find the letter. And if we get to the end of the word, that means that we found all the letters. if we get to the end of the word, we found all the letters. And if we go through and do a depth first search on the whole board for every single letter, then we and we don't get to the end of the word, then we'll return false, that the word is not in the board. So it is a straightforward algorithm, but it's a little difficult to code up. So let's see the code. So for this code, we are going to need some variables to start. We're going to need the number of rows. So our number of rows is going to be the length of the board, and our number of columns is going to be the length of one of our rows. And we're going to have a depth first search function, and it's going to take I, which is the index of the word that we're currently looking at. So we are going to take I, and then we're also going to need the row and column that we're currently at. So, okay, so we're going through our function, and when are we going to, what's our base case? Well, if our I is out of bounds, so in our picture, we could look up, down, left, and right. But if there was no letter to above or no letter to the left, then it was out of bounds. So it can be out of bounds. So if I is out of bounds, where, well, first of all, let's take care of if our base case of if we found our word. So if I is equal to the length of our word, if we got to the end of the word, then -1, length of the word -1, or if I is equal to the length of the word, that means I is after we've finished the whole word. So if we finish the whole word, that means we found it. We found the whole word in the board. So we're going to return true. And now we'll take care of if we're out of bounds. So if our row is less than 0, or if our row is less than 0, or our column is less than 0, then we're out of bounds. Or if our row is greater than or equal to num rows, then it's out of bounds. Or if our column is greater than or equal to our num columns. So those are out of bounds cases. So what if we get to we look to the left or we look to the right, and the letter that we find is not the same as word at I. So that's also we want to return false. So if our word at I, that's the letter that we're currently looking at, is not equal to our board at row column, then we'll return false. And finally, our last case was we can't use we can't reuse a letter in our path. Like, we can't go backwards. So we're going to need to keep track of our path. So we're going to have a path set, and this is going to be all the letters that we visited in our path. So we're going to be putting in the row and the column in the path set. So or our row column in path, then if any of those are true, we're going to return false. So if none of those are true, then that means we've actually found a letter, and that's good. So if we found a letter, we need to look for the next letter. So what we're going to do is we're going to recursively call this function, and we're going to look up, down, and left and right. So we're going to say our result is equal to depth first search of, and we're going to give it I plus 1 because we're looking for the next letter in the word. And so now we need to give it our row and column. So we're going to need to look up, down, left, right. So to look to the right, we're going to say row plus 1 and keep the column the same. So we're going to copy this, and we're going to call this 4 times. So we're going to go do a depth first search in all directions. So we're going to look left. We're going to look right. So we're going to say row minus 1. Then we're going to look up. So we're going to say column plus 1. And we're going to look down. So we're going to say column minus 1. So if any of these return true, then we've done a recursive search on in every single direction, and we found a path where we found all of our letters. And so we're going to return result. So this is going to return true if we found it in any of these directions. And then now we need to, so we have our depth first search function. Now we just need to go through our board calling our original depth first search function. So we're going to say for R in, oh, and I'm sorry, I actually forgot, when we're going through our depth first search function, we are going to add our path, we're going to add this row and column to our path, because we're going to go through and we've already found, we've already used this particular position that we're at. And so after we finish doing our depth first search, we need to remove this from the path. So we're going to say path.remove row. This should be a tuple. Remove, and we're going to say row column. Okay, so now we have finished that. So now we're going to loop through all of our rows and columns, and we're going to say for R in range num rows, and for C in range num columns, we're going to call our depth first search function, and we're going to start with 0. So we're starting with the first letter of the word, and we're going to give it the row and column that we are at currently. So we're going to start looking at every possible position. And if this returns true anywhere, then that means we found a path that has the word. So we're going to return true. And if we get through everything and we haven't returned true, then we're going to return false. And that is the code. So yeah, so let's run this and see if we missed anything. So there should be a colon here. And there should be a or here. And then we are missing we need to close this here. And now we're getting a correct answer, so let's submit this. And it was accepted. So basically, this is how you solve this problem using backtracking, looking for the word for the next letter in every direction. So thanks for watching, and I'll see you in the next video.